Hey y'all, it's me, Miss B, and today we're talking about how to solve radical equations. We did a little intro where we focused on foiling, solving, factoring, and solving by factoring. And now we're really going to focus in on how to solve radical equations specifically. And we're also going to do this thing called checking for extraneous solutions. So we're going to go ahead and work through solving this. Okay, so what I'm going to do is I'm going to isolate my square root. So in order to isolate my square root, I'm going to add 5 to both sides. So I have square root of x plus 7 equals x plus 5. All right, then step 2 is I'm going to get rid of the radical. In order to do that, I need to square both sides. So I have x plus 7 equals x plus 5 times x plus 5. That's what the square means. Move this over a little bit. After that, I'm going to expand by foiling. So let me actually write out expand by foiling. So I have first times first, outside times outside, 5 times x is 5x. Inside times inside, and then 5 times 5 is 25, our last two. All right, then step 4 is going to be to solve, and there are a few steps in the solving. So we have 2 different things. A is going to be factoring, and B is isolate the variable. So we are 2 different options here. Okay, so what I'm going to do is I'm going to subtract 7 from both sides and x from both sides. Well, actually, before we do that, let's combine like terms here. So I have x plus 7 equals x squared plus 10x plus 25. Subtract x from both sides and 7, and I get 0 equals x squared plus 9x minus 18. I need 2 numbers that add to be 9 but multiply to be 18, so that's going to be 6, and we want to make it negative 8. Oh, this would be positive 18. So we have 6 and 3. So then I set both of those. Ooh, run out of room. Let's move these over here. Set both of these equal to 0. And x plus 3 equals 0. And solve. So those are my solutions. Now, I do need to plug those solutions back in and see if they work. So we need to, step 5, check our solutions. So, we'll check them here. So I'm going to plug in square root of negative 6. So I'm just taking this equation right here to plug it into. So negative 6 plus 7 minus 5 should equal negative 6. So we have square root of 1 minus 5 equals negative 6. So 1 minus 5. So we have negative 4 is equal to negative 6. That is not true. So negative 6 is not a solution. That is an extraneous solution. Checking for negative 3, square root of negative 3 plus 7 minus 5 equals negative 3. So I have square root of 4 minus 5 equals negative 3. So 2 minus 5, that is in fact negative 3. So that is a solution. So this right here is our only solution to that problem. So this thing called an extraneous solution, it's an apparent solution that is not actually a solution because it doesn't satisfy the original problem. So what we have to do is we have to plug our answers back in. Just like in this last problem, 6 wasn't a solution. It's possible that that could happen quite a lot. So let's do this next one here. I'm going to isolate my radical. That's done. This is by itself. Then I'm going to square both sides. So I'm going to square that. So I have x plus 1 squared equals 2x plus 5. So we got rid of the radical. And then we're going to expand. So we have x plus 1 times x plus 1 equals 2x plus 5. And let's expand further by foiling. So we have x times x is x squared. X times 1 is x. 1 times x is x, and 1 times 1 is 1. So I foiled right there. And that's equal to 2x plus 5. Combine like terms. So now we can solve. So to solve, let's get everything to one side. So I have x squared plus 1 equals 5. Subtract 5. I have x squared minus 4 equals 0. Now I can factor. So this is going to be x plus 2, x minus 2, since we have the difference of squares, meaning that x is equal to negative 2 and 2. So this is the same problem we did yesterday's notes. Okay, we do need to check those solutions by plugging them back in. So I'm going to do x plus 1 squared equals the square root of 2 times negative 2 plus 5. All right, so we have 1 squared, negative 1 squared equals negative 4 plus 5. Okay, so negative 1 squared is 1, and square root of 1 is also 1, so we are good there. Let's check the other one, positive 2, so I have 2 plus 1 squared equals the square root of 2 times 2 plus 5. So we have 3 squared equals 4 plus 5. Oops, root. So we have 9 equals the square root of 9. 9 is not equal to 3, so positive 2 is not a solution. Okay. Finally, our last example here. When we have square roots like this, what we can do is we can set the roots equal to each other. So add 3 radical 2x to both sides. So now I have square root of 4x plus 28 equals 3 radical 2x. So I can square both sides and get rid of both radicals without there being much of a fuss. So I have on this one just 4x plus 28. On this one, I have to take that 2 through. So this ends up being 3 squared times 2x. simplifying further, I just need to solve for x. So moving through here, I have 9 times 2x. That's 18x. Go ahead and subtract 4x from both sides. And I get 28 equals 14x. Dividing by 14, I have 2 equals x. We did only get one solution for that, but we want to check to make sure it works. So plugging it in, we have the square root of 4 times 2 plus 28 equals, minus 3 square root of 2 times 2 equals 0. So 4 times 2 is 8. And 2 times 2 is 4. 8 plus 28 gives us 36. And then from here, we've got 3 times, 2. Since square root of 4 is 2. So then I have 6 minus 6 equals 0. So 0 is equal to 0 is true. So that is in fact a solution. All right.